Hello everyone, welcome back to my YouTube channel. Let's encode the logic. I hope you all are doing good. In this video, we are going to discuss about a program to convert a binary number to a decimal number. So without making any delay, let's quickly jump into the discussion. So let us take an example of decimal conversion of the binary number 1011, which was 11. But how we will compute the decimal conversion of any number to a binary format? Okay, let's take this 1011. So this was 1, 0, 1 and 1, right? So this is the 0th bit and this is the first bit and this is the second bit and this is the third bit, right? Usually to convert this binary number to a decimal number, what we will do is we will multiply this bit with 2 to the power of their bit position. So if you see, this is the bit number and the position of this bit was 0th bit, right? So that's why we did 2 to the power of 0 and the next bit. And this is the bit number 1 and the position of this bit number 1 is at first place, right? So that's why we did 2 power 1 and this is the 0th bit and we did 2 square, right? And this is the bit number 1 and we did 2 cube because it was at third bit, right? So in this way we will convert the decimal conversion of a binary number. Simple. Now we need to write a code for it. So before that, let's figure out the logic. My logic was very simple. We just need to convert this calculation into a code format. That's it. If you observe, these are the bit numbers. This is bit 1, bit 0 and bit 1, right? So what we need to do? We need to extract these bit numbers, right? We need to extract them individually. We need to separate them. After extracting, we can easily multiply with 2 to the power of their bit positions, right? So now the question was how we can extract these bits. So for that, instead of considering 1011 as a binary number, consider it as a decimal number. So let's say this is the decimal number. Let's take n equal to 1011, right? So to extract the digits from that number, let's perform n mod 10. So if we do this 10 and then 1011, right? So 10 1010 1010, right? And my remainder was 1. This is the 0th bit. This is nothing but the 0th bit. And if you observe the quotient, which is the remaining part, right? Again, take this quotient and do 10 mod 101. So if we do 10 tens are 100, right? And my remainder was 1. And if you see, this is the first bit. And if you observe the quotient, which is the remaining number, right? Now let's again take this 10 and just perform 10 mod 10. So 10 ones are 10 and my remainder was 0, which is the second bit, right? And if you observe the quotient, which is the remaining number, right? Now again perform 1 mod 10. So 10 zeros are 0 and my remainder was 1. Now we got the third bit also. And if you observe, once all the bits are extracted, then my n will become 0. So in this way, we can extract the bits from the number. So let's write down the logic first. So we are doing n mod 10 to get the bit, right? And once we got the bit, what we need to do? We need to multiply our bit with the bit position, right? Initially, the position of the bit was 0. So I will do bit into 2 power of position, right? And after computing this, what should I need to do? I need to preserve it by adding it with some another variable. Okay, let's take a variable that was answer variable and initialize it with 0. And I will do answer plus equal to this result. I need to increment by position, right? So in the first iteration, my position was 0 and in the second iteration, my position will become 1 and then 2 and then 3, right? So that's why I incremented by position. And also one more thing, in the first iteration, my n was 1011 and in the second iteration, I was considering my previous iteration quotient as n, right? And in the third iteration, my n was 10, right? The previous iteration quotient and this is my n. So I need to perform n by 10 and I need to make it as n equal to n by 10. So this is the logic, guys. So now we need to write a code for it. So before diving into the coding part, let's figure out the logic in simple words. At first, we need to take the input, right? The input was this binary number. Later, we need to apply this logic. So for that, I will use a while loop, right? And then finally, I will print the output that was the answer variable, right? Simple. Now let's write the code for it. So let me keep a comment first. Program to convert binary to decimal. Now we need to take the input n equal to int of input of enter binary number, right? And then I will use a while loop. So what is my while condition? Where should I need to go till? I need to go till my n will become 0. Once my n will become 0, then I need to stop my iterations, right? So this n equal to 0 will act as a terminating condition. So I will check if n not equal to 0, I need to perform an action. So what is my action? So this is what we need to perform, right? So at first, I will do bit equal to n mod 10. And later what we are doing? We are performing this, right? For that, we need to initialize our position and answer variable as 0, right? Okay, let's do that. So position equal to 0 and answer equal to 0. So I will do answer equal to answer plus bit into 2th power of position. Later, what we are doing? We are incrementing our position, right? So position plus equal to 1. And then we need to make our previous quotient as n. So I will use the float division to get the precise value in Python, right? So this is the logic, guys. Now let's print the output finally. So print the decimal conversion of n is answer, right? And if I keep n here, then my output will be like the decimal conversion of 0 is, because after completion of all these iterations, my n will become 0, right? How can I restore it? Simple. Just store it in some another variable, num equal to n. And here, keep num. Simple. So this is the code, guys. Now let's run this program. So I will give 1011. So if you see, the decimal conversion of 1011 is 11. Fine. Let me run this program again. I will give 101. Let's consider only bit number 1 positions. So this was 2 power 0 and this was 2 square, right? So 2 power 0 plus 2 square, which is equal to 5, right? So the decimal conversion of 101 is 5. Simple. Now let's again run this program. 1010110. So that was 86. So in this way, we will write a program to convert a binary number to a decimal number, guys. I hope you like this video and thank you for watching. Hey folks, if you enjoyed this coding tutorial and found it helpful, don't forget to give it a thumbs up. Share it with your fellow coding buddies, drop a comment with your thoughts or questions, and of course, hit that subscribe button and ring the notification bell so you never miss out on our latest content. Your support means a lot and it helps our community grow. Happy coding!